Hey guys, so now I'm going to start a mini series from this video onwards. It's going to be called Let's Make, and I'll be making certain things throughout these I'll be making mini series within this series, and in each mini series we'll make something. And I have some cool things planned. So the first things we're going to make is TensorFlow, and when I say let's make TensorFlow, I don't mean I'm going to make exactly what Google has made. I obviously can't do that, but I'll definitely try to cover all the basic functions so that if you want to build on this, it shouldn't be too hard for you. You can use my code definitely as a skeleton to go ahead and do whatever you want. So let's try to understand how TensorFlow works first before we go ahead. So when I was looking up for some resources, this Medium article is something which I found really useful. It's called Understand TensorFlow by Mimicking its API from Scratch. Huge shout out to Dominic E for writing this Medium blog. It's really, really good, and I strongly recommend everyone read this blog entirely. You can also see that it's pretty famous. It has 5.9K claps, which is pretty cool. And he explains all the fundamental aspects of TensorFlow. He's not going to make a neural network here. He is just making a computation graph for this arithmetic operation, which is a pretty fundamental operation. But it will really make you clear. It'll make you guys understand how TensorFlow works behind the scenes. So you guys just write model.add, model.fit, right? So you guys don't see all the heavy lifting TensorFlow does behind the scenes. So this will give you a great idea of how that happens. This is the computation graph for the process which I showed you just now. This AB, and then we multiply it, add it, and then divide both. So this is the computation graph for that. So first, let's try to understand what a computation graph is. A computation graph is nothing but first of all, it's a global variable. And if you don't know what global variables are in Python, global variables are something which can be accessed by every function. So let's say you declare a variable within a function, you can access it only inside the function. But if you have a global variable, any function or any part of the code can access that variable, modify it, uh, change it, do whatever you want with the variable. So your graph is a global variable. Uh, I wouldn't call it a variable. I should probably call it a class. It's a global class which has information about what operations need to be done, right? So this is the computation graph. Here, the computation graph consists of certain elements. I'll show you the few of the basic elements are variables, placeholders, constants, operations, graphs, and sessions. So let's try to understand these. I'll try to explain this blog in a simple way, but I still strongly recommend reading the blog completely. So this is the computation graph, and 15, 5, multiplication, addition, division, print, all these are nodes, right? Now within nodes, we have further classifications. 15 and 5 are constants, multiplication, addition, division, print, all these are operations, right? And this entire thing is the graph. Cool. So let's try to understand what the others are. Placeholders. So a placeholder is something which you use when you are going to say that save some memory for me, I'll give you a constant, or I'll give you something later. So a placeholder does not take up memory in the computer. This is a common misconception which people have. It is just an empty node. It does not, let's say your integer is 4 bytes. It does not take up 4 bytes. It just holds something. It's just a declaration that 4 bytes will come in later, but only when you run a session the 4 bytes will actually be taken up. So from there, let's try to understand what session is. So a session is basically something in which all the memory allocation and all the execution of the computation graph happens. So until you run a session, your memory is not consumed in your laptop or in your system. So a graph is something which facilitates all the operations. A session is something in which all the operations happen. So a graph just declares all the operations and decides the order in which the operations should happen. But a session is where all the operations actually happen. So now we know what placeholders are, what graphs are, and what constants. And constants, I mean, it's pretty self-explanatory. It's something which cannot be changed. So let's try to understand the difference. So let's say I write a is equal to numpy. NP stands for numpy. I hope you all know that. NP dot zeros of some number. Here he has taken e power 12, which is, I don't know why, it's quite a huge number. But when we write this, when we write a is equal to numpy dot something, that memory immediately gets allocated in the computer. But when I write a is equal to tf dot zeros, the memory is not allocated. It's written here, not allocate the memory until the graph is executed. And the graph gets executed inside a session. So until you run a session, nothing, no space is consumed in your laptop. Only the graph is designed. That means only the flow of operations is defined. But until you run a session, no memory is consumed, no operations are performed. I hope this point is very clear, because this is a very fundamental of functioning of TensorFlow. Now, this is how you write the same code in TensorFlow. Like if you import TensorFlow, you just declare constants. You just say multiply, add, divide, and then you say session dot run, and then you run this final result, so that the entire computation graph gets executed, right? So there is a way in which this computation graph is read. Oh, please go through the theory here given here. He explains why graphs are used in a much better way, and he explains how to implement this in code as well. So please go through that. I'm just explaining this as for the bare fundamental understanding, so that you don't face much difficulties in the next video. So let's say you know all these constants, you know what a constant is. Now this GIF or GIF or however you pronounce it explains exactly how a computation graph is read. So the computation graph is defined. So now we start going back. So first we encounter division, then we encounter multiplication, then we encounter 15. Now while coming back, we encounter 15 again. So 15 is put here. So as you can see, division, multiplication, 15, then 15 again, so 15 is put here. Then 5 again, 5 is put here. Then multiplication again, put here. Addition again, put here. Division again, put here. And then we have a stack. Now, once we have this order, we know how to perform these operations, right? So let's say this sorting is called the topology sort. People might also call this as depth first search. If you are from the data structures and algorithms background, you might know this as a depth first search, where you recursively iterate over a tree, and when you find the same element, you pop it off. So this is a fundamental idea of what's happening behind TensorFlow. Now, in the next video, we'll try to actually implement this in code. So what I mean by that is, I have written two codes. One code where I define the graph, where I define what model is, and where I define functions like add input, predict, model.fit, and I define what an input layer should look like, what a dense layer should look like. We write custom code for all that, how a forward propagation should take place, what is an activation function. We write code for all that, and I also have another run function, another run file, where I import this basic NN as TensorFlow, as TF, right? Normally, what do? We import it as import TensorFlow as TF. Okay, sorry for the error. TensorFlow as TF. Here, instead of that, I'm going to import basic NN as TF. So we are going to call all the custom classes we have inside here. And then what we're going to do is, we have model is equal to tf.model. I declare a model. Then I do model.add tf dense, and I say input shape is 4, just like how we do it with the normal TensorFlow. Then I add an activation to this. I add with the ReLU activation. Then I can go ahead and I can add one more layer if I want. It's your wish. You can go ahead and add 10 layers if you want. So after that, I'm going to do model.predict just to see with the initial weights whatever output comes. Then I'm going to apply model.fit. And I'm going to teach this TensorFlow to learn a very fundamental relationship. So this list has 1, 2, 3, 4. This list has 2, 3, 4, 5. So if I ask you the relationship between this, you can obviously tell me that, let's say the first input list is x and this is y. So you're going to obviously tell me y is equal to x plus 1. It's very apparent to you. But let's try to teach this relationship to a computer. Full disclosure, this is kind of a spoiler alert, that this neural network won't perform that well, because neural networks are not meant to learn such simple relationships. The non-linearity in this relationship of y is equal to x plus 1, there is no non-linearity. It's a very, very simple relationship. And neural networks are not meant for this. Machine learning, as we know, machine learning models are meant to learn relationships like this. So something like linear regression would be a perfect place where you could train something like this. So the neural network will perform very bad on something like this just because this is not a deep learning problem. Learning such a simple relationship is not what deep learning is meant for. Deep learning is meant for very complex problems where there are huge non-linearities between your input and your output. So then we'll predict it after training just to see how well the model has learned whatever it has learned, and then we'll see how it goes. So we can also declare how many epochs we want the training to go for, and we can also declare the training rate explicitly. So it's going to be a really exciting series. I'll try to keep it short, and I'll try to keep it I'll try to finish it in around 4 videos or 3 videos. I'll try my best. So I hope you guys learn a lot from this, and I hope you guys really like this series. All right. See you in the next video.